Okay, for 1a, we're going to attempt direct substitution. It's going to fail. We're going to get 0 in the bottom. So whenever we have a number over 0, that indicates the presence of a vertical asymptote. So what we can do is just go ahead and try to graph this super quickly. So when I go to graph this, I'm going to have vertical asymptotes at +1 and -1. I'm going to have an x-intercept at -6. I will have an end behavior asymptote at 0 and a y-intercept up at -6. Okay? And that's everything I need in order to sketch it. So right here, I know that I'm stuck down here with odd multiplicity asymptotes, and the only place I can cross the axis is right there. So I have a complete graph off of that. So I can now figure out the limit as we're approaching -1 is going up on the left and down on the right, which means that this limit does not exist. For b, same idea. I get a number over 0, so I know that this is going to give me a vertical asymptote. So I have vertical asymptote at 0, and I have an end behavior asymptote of approximately 2x, so I'm just going to guess it. And let's see, I could attempt to try to factor this, or I could just probably plug in a number. It would be just as fast. So let's see, I'm going to plug in like 10 and see if I get a positive number or a negative number. So I'm going to get a big positive number. So I know that if I plug in 10, I'm going to be way up here. And it's going to go like this, and it's going to go like that. I'm not going to lie, I cheated a little bit and used a calculator. Don't tell anyone. So let's see, we're really being asked just from the left-hand side, so this is going up towards positive infinity, so that's going to be the answer. Okay, for C, we try direct substitution. We get a number over 0, so that did not work out. Let's factor this real quick. I think it factors to 2 times x minus 5 squared. Okay, so we have an even multiplicity asymptote. That's useful to us. So I'll just do a quick sketch of this thing. I'm going to have asymptotes at square root of 7. Not asymptotes, sorry, my bad. Intercepts at square root of 7 and negative square root of 7, wherever those are, I have no idea. I have a y-intercept of -7 over 50, so that's somewhere down here. I have a end behavior asymptote at 1/2, that's chilling right there, and then I have this even multiplicity at 5, which I know is bigger than square root of 7, okay? Because the square root of 25 would be 5, so I know that square root of 7 smaller than square root of 25, okay? So we end up with all of this stuff. That's going to give me some sort of graph that kind of goes down and then up and then over like this. So I know that this is going to be positive infinity. This one's a little bit trickier. It does tell us that we can use the calculator in order to figure this out. And I'm going to give us a little tiny shortcut actually that we can use. So what I'm going to do is first just think about cosine. So cosine goes like that, and this is pi over 2. So that's why we get 0 in the denominator. But right above that, we would have a positive number here. So let's pretend for a second that we plugged in, direct substituted in, a number slightly to the left of pi over 2. So on top, I'll just plug in pi over 2 because I didn't actually get 0. And on the bottom, I'll plug in this number that's slightly to the left, right? So up top, I'm going to get pi minus 4. So that's a negative number. And on the bottom, a number slightly to the left is going to be positive. And this is actually all I need in order to know that this is going to be negative infinity. So whatever the sign is, when we plug in a number slightly less than it on the left or slightly bigger than it from the right, that's going to tell us whether we would be positive or negative. For example, if we had done this from the right-hand side, the top would still be a negative number, but the bottom would end up being a negative number as well. So a negative would give us positive. So I know that from the right-hand side, this is going to be positive. A little shortcut for the, I don't know, -2 of you who are watching this at this point. Okay, for E, we try direct substitution. It fails. We get a number over 0, so we know there's a vertical asymptote chilling here. I'm going to have that vertical asymptote at 1. It's got a multiplicity of 3. I have an x-intercept and y-intercept at 0 and an end behavior asymptote right there. So I need to plug in another point in order to see what's really happening here. So if I were to plug in something like 2, okay, which would be over here, I'll get a negative number. So I know that this graph is going like this. Okay, so if I want to know what's happening on the right-hand side, it's going down towards negative infinity. If I'm over here with this one, I can direct substitute in. I'll get 0 over 0. So the first thing I'm going to do is attempt to just simplify this. So if I do that, I will get an x minus 1 over an x plus 1 to the 4th. Okay, so I still can't direct substitute because I still get 0 on the bottom. And I have vertical asymptote at -1. It now has a multiplicity of 4 since I've reduced it. X-intercept at +1. A y-intercept at -1, and behavior asymptote at 0. So that's everything I need. It's going to go like this and like this. So the actual limit as we're approaching -1 is going to be -infinity. Okay, for 3a, I don't know what happened to 2. I'm not really sure if my answer key's just numbered wrong or what. I don't know, but we're evaluating this at infinity, so I'm just going to plug in infinity, and when I do that on top, I basically can ignore the 4x because the 7 infinity to the third is going to be much bigger than that. On the bottom, we'll have 2 infinity to the third. The infinity to the thirds cancel, so I am left with 7 over 2, and that's going to be the limit as x approaches infinity. Same idea over here. This time, it's the -3 infinity to the 4th that's going to matter, and the 4 infinity. So when I simplify these things down, I get a -3/4 infinity to the third, which, is basically just -infinity. Plug it in, we'll get 51 over 1 plus the square root of infinity. Fun fact, the square root of infinity is still infinity, and infinity plus 1 is infinity, so this is really 51 over infinity, which is going to approach 0. Okay, for 4, we are being asked to find the limits as x approaches positive infinity and as x approaches negative infinity. So let's plug in positive infinity here. We will get the square root of infinity squared plus 4 infinity all over 4 times infinity plus 1. So up here, this infinity we can ignore. The square root of infinity squared is just infinity. And on the bottom, we can ignore the plus 1. So we just have 4 infinity. Those cancel, and we're left with 1/4. So that's the limit as x approaches positive infinity. Let's do negative infinity. The top is going to pretty much remain unchanged. Let's see, that will end up being a -4 infinity when I plug in negative infinity, and I get a -4 infinity plus 1. So on top, again, this basically we can ignore. We're squaring it, so that's positive, square root of a square, positive infinity. On the bottom, we get -4 infinity. So this one's going to be -1/4. B, same idea. I'm going to plug these things in. I can essentially, because there's nothing unusual going on here, there's no square roots, there's no things in exponents or anything, just normal everyday polynomial functions being divided by each other, I can essentially ignore this and rewrite it with just the biggest exponents, which will reduce down to 1 over 2x. So when I plug in both positive and negative infinity to the denominator, this is going to be approaching 0. So the limits for both positive infinity and negative infinity will just be 0. All right, for C, again, we just have pretty normal polynomial over polynomial, so we can essentially just take the biggest exponents for each part of these things. There's no 3 there, sorry. And just reduce, so this is going to be 5x squared. So when I plug in positive infinity into this, it will stay as infinity. So as x approaches infinity, the limit is going to equal infinity. And then when I plug in negative infinity, it's squared, so it's going to also be positive infinity. So if this wasn't squared, then this wouldn't have been positive infinity. They wouldn't have been the same. So we have to still be a little bit careful when we're using shortcuts. For D, let's do, as we plug in positive infinity, I will get a -3 infinity plus 1 over 4 times infinity squared plus 1. So if we just reduce the top, that's -3 infinity. On the bottom, the 1 we can ignore. The square root of 4 infinity squared is going to be 2 infinity. Those infinities cancel. We're left with -3 over 2. When we do x approaches negative infinity, up top we'll end up with a +3 infinity plus 1, and in the denominator we'll get 4 negative infinity squared plus 1, so that's going to be a 3 times infinity on top, and the squared makes it positive, so we'll end up with a 2 infinity. So this one will be 3/2. So as x approaches positive infinity, it's -3/2. As it approaches negative infinity, it's +3/2. E is where we start getting a little bit tricky. First thing we're going to do is just try to see which one is the biggest exponent. So an x, square root of x is really x to the 1/2. This is really an x to the 1/3. So if I compare these, 1/2, 5/8, the 5/8 is bigger. So I'm going to have, let's see, when I plug in x equals positive infinity, when I compare the top, an infinity to the 1/2 or an infinity to the 5/8, I'm going to end up with the infinity to the 5/8. On the bottom, same idea. I have 2 times infinity to the 5/7 minus an infinity to the 1/3. So I'm going to focus just on the 5/7 because it's the larger one. Now I need to figure out which one of these is larger. And let's see, 5 pieces of 7 will always be bigger than 5 pieces of 8. So this is going to be larger in the denominator. So if I have a small number on top, large number on bottom, this is approaching 0. Now we have a tricky thing with negative infinity, because if I go to plug in negative infinity to the very first thing, we can stop right there. We have domain issues. So we can just say this one does not exist. It's actually a dumb question to even ask it, because the domain of this stops at x is greater than or equal to 0. I don't actually know if it's or equal to. I think it's actually not or equal to. Should clarify. All right, this one. So this is really 1 over x plus 5 squared. So if I plug in positive infinity, I have 1 over a big number, that's going to 0. If I plug in negative infinity, it's 1 over a big number, that's going to 0. So both of these ones are going to 0. Why are there so many of these? My goodness, what was I thinking? Okay, for g, I'm just going to actually evaluate each one kind of separate. So as I'm doing as x approaches positive infinity, over here, this part's going to approach infinity. And this part, let's see, the 1's going to cancel, the x's are going to end up canceling, we're going to be 3. So we have infinity plus 3. So I know as x approaches infinity, our limit is going to be approaching positive infinity. Now when I approach negative infinity, let's see if things change. We're going to end up with 2 times negative infinity squared over negative infinity minus 1 plus 3, so negative infinity there, and then a negative infinity plus 1. So this will be positive up top, so I'll have 2 infinity squared over a negative infinity. That will end up canceling. So this ends up now being negative 2 times infinity on top. And let's see, that's gone, those are positive, so this will be plus 3. So this is actually going towards negative infinity. Okay, so as x goes towards positive infinity, the limit's going to be infinity. As it goes towards negative infinity, it will be negative infinity. This is another one of those weird ones where we have to pay attention to what's going on with this stuff. So up top, we'll have an infinity to the 3/4. We can ignore the 5. On the bottom, 5/6 is bigger, so we have a negative infinity 5/6. Now we just have to know which one of these is bigger. So 5/6 is bigger than 3/4. So that means bigger on bottom, so this is going towards 0. When I try to do x equals negative infinity, I have those domain issues. This x to the 1/2. Remember that that's really the square root of x, so I can't do a square root of a negative infinity. So this one does not exist. It's a pretty dumb question to ask. All right, let's think about this one. Missed some equal signs there. Sine. Sine is always between -1 and +1. And it doesn't matter what we put in there for x. It's always between -1 and +1. So that's always a small number. So as x approaches positive infinity, we have a small number over infinity. So then our limit is going to be approaching not infinity, 0. Small number over big number, 0. Same thing happens with negative infinity. We'll have a number between -1 and 1 and an infinitely large number, so this one's also going towards 0. If we were to graph this, I don't 100% know this, but my guess is that it's basically going like this and alternating back and forth over this towards the end, and then it probably does something like that in the middle. That was a guess. I don't know. You graph it. Tell me if I did it right. Over here, we have to be careful because of this term right here. So as x goes towards positive infinity, we'll get an infinity to the 7th minus infinity to the 3rd over 2 plus 3 to the infinite power. So if we reduce this, remember we compare tops first, so infinity to the 7th, and then we'll have a 3 to the infinite power. Now we have to know which one of these is bigger, and anything to the infinite power is going to be bigger than an infinity raised to the 7th. So this is big on bottom, so it's going towards 0. If we do towards negative infinity, we have to be careful here. We're going to get negative infinity to the 7th minus negative infinity to the 3rd over 2 plus 3 to the negative infinite power. So here, the top, we're going to just have negative infinity to the 7th. On bottom, this is approaching 0 because it's 1 over 3 to the infinite power. That's what the negative exponent does. So the bottom is actually just 2, which means this is approaching negative infinity. For letter K, let's think about this. So this is always going to be between -1 and 1, so we can basically ignore it. So we're going to have 1 over 2 to the infinite power no matter which way we go. So both of them are going to be 0. For L, when we're looking at this, we basically want to compare the exponents for the first part. So as x is going towards positive infinity, This is to the first, this is to the 7/5, so that's bigger. So I'm really going to have a negative x to the 7/5 on top. 1/3 compared to 4/3, the 4/3 is bigger, so I have x to the 4/3. Now I just need to compare which one of these is bigger. So 7/5 is bigger than 3/4, so this is going to be big on top, which is going towards positive infinity. When I do negative infinity, I just have to make sure I don't get domain violations. So since all of these are odd-powered roots, I don't need to worry about putting a negative on the inside. So I can essentially just see what happens to the negative sign as I evaluate it through all of these. So I'll do this one all the way out. I'll get a -3 times infinity minus 5 negative infinity to the 7th all over 2 negative infinity to the 1/3 minus the cube root of negative infinity to the 4th. So if I look up top, I just need to figure out which one of these is bigger. So it's still going to be the 5/7 one, but I need to know what happens to this negative sign. It's going to cancel with that negative sign because everything's odd. So I'm really going to have an infinity to the 7/5 over here, positive. Down here, the 4/3 is still bigger, so I can ignore this. But this 4 right here makes this positive, so this will stay as negative infinity to the 4/3. So now I just need to know which one of these is bigger. It's bigger on top, but I have this negative sign. So this one's going towards negative infinity because of that extra negative sign. All right, so again, cosine, it's going to be between -1 and 1, aka it's always small. So when I plug in infinity, so let's do positive infinity, I'm basically doing infinity minus a small number over infinity, so I can ignore that, and I get infinity over infinity. So as x goes towards infinity, this limit is going to be approaching 1. Same thing happens when I plug in negative infinity. I'll get negative infinity minus a small number over negative infinity. Small number can be ignored. These are the same, so they cancel out. So as x approaches negative infinity, the limit is still approaching positive 1. Last but not least, in this section, I believe, we got the limit as x is approaching infinity. So let's see, we're going to have infinity to the 1/2 plus 3 over infinity plus 3. We can ignore the plus 3's. This infinity is larger, so small over big is going to be 0. When I attempt to do the limit as x approaches negative infinity, I have this square root of a negative number right here, so this is not going to work. It does not exist. This is a dumb question for me to be asking you, essentially. All right, numbering is all over the place in this practice section, so I'm magically back to number 1 in the trig section here. So I just wrote down the ones that we need to memorize just so that we can be paying attention to them. What I'm going to do here is basically separate this out into 1/2 times sine x over x. The limit of a constant is that constant. Limit as x approaches 0, sine x over x is 1. So this is going to just be 1/2. Over here, this looks awfully close to this, but it's a little bit backwards. So when I separate this out, I'm actually going to factor out a negative sign from the top. So I can write it like this by separating things. So limit of constant is that constant. This is going to be 0. Negative 1/3 times 0 is 0. Okay, I'm just going to separate this out. I'm going to do 3 times sine x over x times cosine x. So limit of a constant is that constant. Sine x over x as x is approaching 0 is 1. Cosine of 0 is 1. So this is going to equal 3. For this one, I imagine we're going to be using the opposite of this guy, which basically is x over sine x equals 1. So let's try to rewrite this. A tangent on the bottom is really a cotangent on top, and a cotangent is really a cosine over a sine. So I'm going to separate this out as x over sine x times cosine x. Limit of x over sine x is going to equal 1. Cosine of 0 is 1, so this is going to equal 1. I'm going to factor out 3 from the top, so I'll have 3 and then 1 minus cosine x. I'll pull the 2 and separate that from the x. Limit of a constant is that constant. This is going to equal 0. 3/2 times 0 is 0. Over here, cosine times tangent. Well, that's just sine. So this is really sine x over x. The limit as x is approaching 0. That's by definition equal to 1. Haha, that one was easy. For 7, I'm just going to try direct substitution. I get 0 over cosine of 0. That's 0 over 1, which is 0. And we're done. So just remember that they could try to trick you here, and it could still just be direct substitution, even though it looks like it might not be. 8's a tricky one. We got this 5x and this 5x. So what I want to do is create this new letter. I'm going to say let u equal 5x. So if x is approaching 0, let's multiply this by 5. That means that 5x would also be approaching 0. I just multiplied both sides by 5, which means that u is approaching 0. So I'm going to rewrite this then as the limit as u approaches 0 of sine u over u. And that fits that right there. So I know that this is going to equal 1. Ta-da! Math. For 9, I'm going to factor out this 5. So I'll have 5, 1 minus cosine x all over x. Limit of a constant is that constant. 1 minus cosine x over x is 0. 5 times 0, 0. This one, it is trying to trick you like we did with 8, except that we can just direct substitute here. We can just get, this will be sine of 0 plus 1 over 0 plus 1 is just 1. So whatever sine of 1 is in radians, that's what this is. So that's like 0.8415. So they tried to trick us. Okay, this big piecewise one. So what makes these hard is that they just pretty much combine everything into one giant question. So I'm going to start off with labeling each one of these intervals as A, B, and C, and then come over here and look to see which one these things fall in. So when I look at x approaching -2, from the left it's in A, and from the right it's in B. So I'm going to come over here and just put a little A and a little B right there. For x approaching, this is -4, my bad, got this all written wrong. Negative, negative, negative. Okay, -4, that is firmly in A. So both of these ones are going to just be in A. When I look at +1, that's very firmly in B's interval, so both of these ones will be B. 6 is firmly in C's interval. Now 5 is the cutoff between these, so from the left it's in B, and from the right it's in C. So the reason we do that is because now I don't need to pay attention to which equation to pick. I'm just going to evaluate based on the A, B's, or C's over here. So let's do this from the top. I'm going to start with this guy right here. Remember, I can't do any of these until I've already done these. By definition, these two have to be equal for this one to exist. So if I start over here with -2, what I would normally do is see if I can direct substitute, but I'm just going to simplify this one first real quick. So I'm going to have x plus 6 over, and that's actually x plus 4 squared. I just wanted to do that to make sure that nothing weird was happening. So when I plug in -2 to this, I will end up with 4 over, let's see, what is this? 2, oh my god, I just forgot how to do math for a second there. -2 plus 2, that's going to be 2 squared, so that's going to be 4. So this is going to be 1. So this one is 1 right there. Now let's plug in to B. Let's see what happens if we do that with -2. So I'm going to get 3 minus the square root of 9 over, let's see, 2 squared, that's going to be over 3. So let's see, this is 3 minus 3, so that's going to be 0. Okay, so that one's 0, those are not the same, so this one does not exist. Done. When I look at 4, which is firmly in A, when I take a peek at this, that's a vertical asymptote that's happening at -4, so I'm just going to super quick graph this just so I get an idea of what's happening with things here. X-intercept way over there, there's a y-intercept that's somewhere here. So I know that this is going here, this has an even multiplicity, so it's going something like this. So I know that this is going towards positive infinity from both the left and the right, which means the actual limit is positive infinity as well. For 1, when I'm looking at this, this also happens to have vertical asymptotes going on there, which is just a big pain in the butt, but that's okay. We'll try to figure out what's going on with this. We'll do a super rough sketch of B. We have vertical asymptote at +1 and at -1. We have an x-intercept somewhere. I honestly have no idea what this thing is doing here. Let's focus on y-intercept. It's going to be negative, negative. It's going to end up being positive. Okay, so I'm going to be somewhere up here, and I really wish I knew where this was. I really don't want to do this crazy math, but it looks like we have to. So I'm going to set the top equal to 0. So that gives me 3 equals the square root of all that stuff. So 9 equals x plus 11. So I will subtract that over, and what's that going to be? -2. X equals -2. So I'm way over here. And that's the only one. So now I know everything that I need to know about this thing. It kind of goes like this, I believe, is what's going on with it. So as I'm approaching +1, this side is going up, and this side is going down. So I'm at positive infinity and negative infinity, which means the actual limit does not exist. Whew, that was a tough one, I gotta be honest with you. For 6, it's very firmly in C, so I'm just going to try direct substitution and see if that works. I don't know if it does or not, but I'll get 6 minus 4 over 36 plus 24 minus 21. I don't think that's going to cancel out. Let's see, when I do all of that fancy math, I think that's just going to be 2 over 39. And since we were able to direct substitute, that is going to be the answer for all 3 of these, okay? Last but not least, as x approaches 5, so in this equation, we can just try direct substituting. Okay, so I'll do that. That's going to be 3 minus, that'll be the square root of 16 all over 25 minus 1, so that's 24. So this is going to be a negative 1/24 when I simplify that. Now I'll plug it into C's equation. I will get 5 minus 4 over, and what is that? So that's going to be 25 plus 20 minus 21. Okay, so I think that's positive 1/24, which is not the same number, so this does not exist. Whew, that was rough. Oh, we have a whole nother one to do. All right, as per usual, first thing I'm going to do is just come in and label these A, B, and C, and then look over here to see where these intervals fall. So for these ones, they both fall in A. -1 from the left is in A, -1 from the right is in B. Zeros firmly in B for both of these ones. 4 is very firmly in C for both of them. 2 from the left is in B, 2 from the right is in C. So again, that's just to help us so we don't have to pay attention to as much things later on. Alrighty, let's look at -2, which is going to be in A. First thing I would try to do is direct substitute. I end up getting 0 in the denominator, so I'm just going to sketch a quick graph of that. Vertical asymptote at -2 with a multiplicity of 4, x-intercept at -1, end behavior asymptote at 0. Y-intercept is positive something, I don't really know what, but that was enough for me to figure this out. It's going to go like that, kind of follows that, and then multiplicity like that. So they are both going down towards -infinity. So this one's going to be -infinity, this one's -infinity. Since both of those are -infinity, so is the actual limit. Okie dokie, for -1 from the right-hand side. All right, we actually already figured that out for A, from the left-hand side. For A, we already know that that's going to be 0, so I'm not going to do any math for that. We've graphed it. We've already plugged that in and figured it out. For B, when I go to plug in -1, let's see what we get. We'll get tangent of -pi over -2. Okay, so tangent of -pi, what is that going to be? That's equal to 0. Okay, so this is going to be 0, and since they are both 0, then the actual limit is 0. For 0, which we're firmly in B, I can't direct substitute because I get 0 in the bottom, but what I can do is rewrite this a little bit. It can be a little bit fancy, I think, but we'll have sine of pi x, and then over a cosine pi x, so there's my tangent, and I'm just going to separate some things out here. I'm going to have a 1/2, and I'll put the x here. Okay, so I have to do a little bit of extra work here that we haven't talked about yet, but right here, in order for this property to work, it needs to be identical, and they both need to approach 0 when x approaches 0. So I need a pi right here to make them identical, but I can't just introduce a pi here. I need it to stay balanced. So by putting one on top and bottom, it stays balanced, and now this will allow me to use the property that says sine of u over u as u approaches 0 is going to equal 1. So then I'll have pi over 2 times 1. Cosine of 0 is going to be 1, so this is times 1. So this is going to be pi over 2. So that one was a little bit tricky, but it was pi over 2, which means this one's pi over 2. Alrighty, then C, when we plug in 4, of course we can't just plug in 4, that would be too easy. We get a vertical asymptote of some sort there, so they just want me to have to graph this one for you, because it's not easy to figure out what that x-intercept is. I have not got a clue. Oh gosh, the y-intercept is positive. Okay, that's at least something. And let's see, I'm going to get x squared plus 7 equals 16. X squared equals, is that 9? No way. All right, so 3 and 3. And so I think that gives me enough to figure out what's going on with this thing. It's going like this, and then it's going like that and like that. So as we approach this from the left-hand side, it's going down towards negative infinity, I believe. Did I do that wrong? I'm not positive about this one. I got to be honest with you. I might have drawn this backwards. So we could attempt to graph this if we want. My answer key has these flipped, so I'm not sure if I did it wrong in the answer key or if I just did it wrong right now. So I don't know. If this is the graph, then that's right. I wonder if I did -4 here, because this fits, my answer key fits what I have for -4. So I'm not sure what I did there. Apologies. I'm not going to fix it now. If I plug in 2 for this, okay, so that will give me tangent of 2 pi over 4. So tangent of 2 pi, that's 0. Okay, so that one's 0. Now let's plug in 2 into this guy. We'll get, let's see, 4 plus 7, that's the square root of 11. And then minus 4 all over 16 minus 4, so that's 12. So that's what that one's going to be. Those are not the same, so this limit does not exist. There you have it.